Hello everybody. The folks over at Inventables.com contacted me and asked if they could send me a Shapeoko 2 CNC milling machine at no cost so that I could put it together and do some projects with it and give them my feedback. So I said, yeah. Inventables sent me what they call the full kit, which includes all of the parts and tools I need to get started in 3D carving. This is the 110 volt version, but it also comes in 220 volt versions and different levels of kits that make it easy for DIYers and hobbyists like me to step into the world of CNC milling. Now the only catch is it comes in about 1 million parts and you have to assemble it yourself. But when I was a kid, I used to play with erector sets and Lego kits all the time. So putting this together is going to be part of the fun for me. So I'm going to set up a nice big clean work surface and let's open the box and get started putting this together. The first few sections of the documentation cover pro tips, software, and electronics. But today I'm going to start with the assembly, which begins with assembling some wheels and idlers. There are 20 wheels and 6 idlers that you have to put together. And the instructions include pictures and exploded diagrams and parts lists to help you through it. The next step in the process is to attach the wheels, idlers, and motors to these black carriage mounting plates. At this point, I need to choose a wiring option, and there are lots of ways that I could wire this up. But they offer 3 options here, and I've chosen option 2, which allows me to connect all the wires with screws. That way I can always change it, as opposed to soldering them. For wiring option number 2, you attach one terminal block to a plate that has a motor with wires coming out the top. And then you attach 2 terminal blocks to the plate that has the motor with the wires coming out of the left side. Now let's move on to the Z-axis assembly. This is what moves the cutting tool up and down. The instructions say the Z-axis rail assembly is the most intricate and complex assembly and requires patience to assemble. Sounds like fun to me. Next up is assembling the gantry. This is the crossbar that moves backward and forward along the Y-axis. And the beginning of the instructions say, if you have not yet finished tapping the maker slides, you can put this off no longer. Gosh, it's like they know me. I guess it's time to tap threads in all 16 holes in the 4 maker slides. Now that I've used most of the parts that came in the small bags and I don't have to spread out as much, I'm going to swap out this plastic table with a nice flat piece of plywood that'll make a good work surface for the rest of the assembly. Now I can put together all the assemblies such as the gantry, the Y-axis, and the base, which is also called the work area. Well, I've got the bulk of the machine assembled, and I did make a few minor mistakes along the way that I was able to correct. The first one was I put 4 belt clips up on top, and there was only supposed to be 1 on each side, so I fixed that. And somewhere along the way, I think I switched this plate with this one, because this ended up being the one with the 2 terminal blocks, so I had to take one of those off of here and put it on the side. And also the motors were rotated, different from the pictures. I'm not sure if that matters, but I just left this one as is, but I was able to take this one off and then rotate it 90 degrees. So the next step is to take this belt and cut it into thirds and mount 1 belt across the top and then 1 on each side. With the belts installed, it's time to start wiring up the electronics, and the kit comes with everything you need, including some wire and a bunch of stuff to help you manage your cables and keep them tidy, like some expandable braiding, heat shrink tubing, and a whole bunch of zip ties. So let's take a quick look at how all the wires are routed. There are 2 Y-axis motors, and I've already routed the wires for this motor through the middle of the maker slides, and they come out here. And it's important to note that these motors need to be wired so they turn in opposite directions, so they will travel together in the Y direction. The Z-axis motor wires get connected to this terminal block, and some of this gray cabling gets connected to the other side of the terminal block, and the gray cable marries up with the cables for this motor, and they travel over to this side with enough slack in the air so that this carriage can move all the way from side to side. Once the wires are gathered here and some connections are made with these terminal blocks, wires are routed to the G-Shield and Arduino, which then get connected to the power supply and the computer. Okay, I've got all the wires connected, and I ended up with X, Y, and Z cables that I need to connect to the G-Shield Arduino. And then I just need to plug that into the power outlet and connect the USB cable to my computer. Alright everybody, now for the moment we've all been waiting for. Everything powered up and tested out okay, and I've loaded some paper and a Sharpie into the machine. So let's run our first job, which is called Hello World. Alright, now that I've successfully completed the Hello World job that everybody does with a Sharpie their first time, let's cut something out of wood. Inventables has this web application called Easel that makes it easy to design things to carve out on the machine. On the left side is your design palette, and you can see the X and Y coordinates, and on the right side is a preview of how it's going to be cut. The first thing we need to do is go to materials and select the material that we're using or something similar. In this case, I'm just going to choose birch, but I'm actually going to cut a piece of pine. My workpiece is 7.25 inches wide, 5 inches tall, and 0.75 inches thick. Over on the right, since I selected birch, it tells me the depth per pass for the cut is 0.028 inches, and the feed rate is 30 inches per minute. Let's click over to the machine tab, and I'm using the bit that came with the machine, which is 0.0625 inches. At this point, I can insert any of these shapes at the top or draw with the pencil. There's also additional shapes in here. To select the shape, you just click on it, and it adds it to your design palette. And at that point, you can resize it if you want. You can tell it that you want to cut the inside of the shape, or you can tell it you just want to cut the outline of the shape. You can also add text by selecting this tool and choosing a font. That will add a text box where you can highlight it and type whatever you want. I've already saved my logo as an SVG file out of Inkscape, but you could use something like Illustrator as well. To import a logo, just go to File, Import SVG, select your file, and open. This will open your logo, and on the right it will show you a preview of how it's going to cut. Now I can tell it's going to cut too deep, so I'm going to click on my logo and I can adjust the depth with the slider here. Or since the depth per pass is 0.028, I'm going to change it here and just tell it to cut 0.025 deep. At this point, I want to size my logo between my 5" by 7.25" board. I need to reduce it a little bit. Now I want to add some text below my logo, so I go up to the text tool and come down to the font I like. I'll choose that one. It inserts a text box, and I can type the text I like. I can move it and position it where I want it and change the size. Now when you're sizing your design elements, you need to take into account the size bit you're using and how small it can cut. For example, if I made this text really small, over on the right in the preview, it would change that text to red, which is a warning telling me that the bit size that I've entered is not able to cut text that small. So what I need to do is enlarge the text until the red goes away, and then I know the bit can cut it. I'm going to center it up, and for this element as well, I need to tell it to cut 0.025 inches too. Now that I have my design set, I can rotate the board by clicking and dragging over here. Since I'm making a shallow cut, it's a little bit hard to see the logo here, but it will cut 0.025 inches into the wood. I've already got my board mounted to the work area with double-sided tape, and the bit is at the home location of 0, 0. So all I need to do is turn on the power to the machine, and then plug in the USB cable. These never go in right the first time, do they? And then I click the Carve button in the upper right corner, and I go through a series of steps to confirm I've set up everything correctly. First, measure the material. Yes, it's 0.75 inches thick. Yes, I've clamped down the material or used double-sided tape. The bit I'm using is the 1/16 inch bit that came with the machine. The bit is in the home position. And the machine is going to raise the bit when I click this button. So let's do it. It works. Alright, now it's telling me to turn on the spindle and then click the button that says the spindle is on. Alright, the spindle is on. So now I just click the green Start Carving button. Alright everybody, while you watch the Shapeoko 2 carve out my logo, I'm going to answer some questions I received while I was posting photos of the build on my Facebook and Instagram. Would you buy the Shapeoko 2 yourself if you did not get it for free? Well, I'm on a tight budget and I don't get to buy new tools very often. But after using it for a few days, I definitely would start building some projects and trying to sell them to save up the money to get one. What is a CNC machine and what does it do? Well, basically it cuts and makes things so I don't have to. But what I'm most excited about is that I can now engrave names and initials and designs into work pieces, and I was never able to do that before by hand and make it look any good. So it kind of fills that void for me in the shop. What software does it use? Well, you can control it using something called a Universal G-Code Sender app. And I had never heard of that before this week. But Inventables has a real user-friendly web application called Easel at easel.com, and you can use that to design things and send things over to the machine. You can also use graphic arts software like Illustrator and Inkscape to save files that you can open up or import into Easel and send it over to the machine. So it's real easy to do, and if I can figure it out, anybody can. Here's a good one. I'm not doubting your skills, but you assembled it, correct? Yes, I did assemble it, and it works too. The kit comes with all the tools you need to put it together, and they have a website with good instructions that pretty much show you every step. Now, there is a lot of reading involved, and a lot of the instructions were more paragraph format. There were pictures. Some of the pictures were small, and you couldn't see a larger version, so that would have been nice. But what I did like about the instructions is that they included a parts list on what you need for every step, as well as an exploded diagram showing how to put it together. So I relied mainly on that, and I got it done. The only step that was kind of tedious was tapping the threads, and I think there were 18 holes that I had to tap. So that was probably the least fun part. So in future versions, if they have the holes already tapped, that would be awesome. How hard was it to put together? Well, it wasn't hard to put together, it was just kind of time consuming. And I was shooting video at the same time, so that had me a little distracted as well. I think if I didn't have that distraction, I probably could have assembled the whole thing in about 10 hours. But since I was shooting video, it took me about 14 to 15 hours to get the whole thing put together. Can you use a Dremel tool instead of a Sharpie? Yes, the kit actually comes with a rotary cutting tool and a bit, so that you can carve wood and other materials. And the great thing about the kit is that it's open source, and you can upgrade to a router if you want. You could take it apart and change it any way you like, and you can even expand it to make it bigger. And I bet this thing might even write you a check if you put a ballpoint pen in it. Here's another good one from a friend of mine. He says, "You know I'm coming over there to play with that, right?" Yeah, I thought that might happen. Oh, and here's my favorite question. Can I make something too, Dad? Yep, my daughter has already been out here and she made herself a plaque. She designed it herself using the Easel software, and I gave her a piece of wood. She mounted it in the machine, sent her design over, and it carved her out. And you should have seen the look on her face. So this thing is great for kids. It's safe, and anything that gets kids in the shop is a welcome addition. Well, with all that being said, thank you Inventables for giving me the opportunity to have the CNC machine in my shop. I really appreciate it, and I'll put it to good use. If any of you are interested in more info, please visit Inventables.com and tell them the Carmichael Workshop sent you. I'll provide links below. Also visit my website at thecarmichaelworkshop.com, where I will have a blog post article about the build and some pictures of the projects I've made so far. Also follow me on Facebook, Twitter, and Instagram, where I will post pictures of future CNC projects that I might not make videos for on YouTube. And thank you all for watching my videos and subscribing to my channel, because I have no doubt that that played a huge part in me being able to get this awesome machine. So as always, thank you all for watching, and I'll see you next time.